Okay guys, today we are going to look at how to conduct a scientific investigation. When you conduct a scientific investigation, there are certain steps that you have to follow, and we're quickly going to go through them today. These are the 7 steps that you have to follow when conducting a scientific investigation. Step 1. Observe. You have to identify a topic and describe what your investigation is going to be about. Step 2. You have to ask questions. So you're going to ask how, why, or when something happens. The question that you write down asks what you want to find out in your investigation. Step 3. Your hypothesis. A hypothesis is like making a prediction. You are basically guessing what the results of your investigation will be. You do not necessarily have to be correct. After the investigation, you might find that your hypothesis is wrong. Step 4. Plan. So to plan for your investigation, you are going to make a list of all the equipment you'll need to conduct the investigation. You also write a step-by-step method of how you're going to conduct the investigation. It's important that you make sure that your investigation or your test is fair. We are going to look a little bit at how to make sure your test is fair later on in this presentation. Step 5. Record data. All the observations you make and all your findings from the investigation is what we call data. Your data can be recorded in tables or graphs. Step 6. Conclusion. Your conclusion describes the data you have collected. So your findings is what you will write down in your conclusion. Your conclusion will also tell you whether your prediction was correct or not. Step 7. Evaluate and communicate. Identify any problems and decide how you can solve them. Think of ways you can improve your investigation and make it better. Your findings can be communicated in a presentation. Now we are going to look a little bit more about each step in our scientific investigation. Step 1 was observe. You have to identify a topic of investigation. Before you can conduct an investigation, you have to first decide what your investigation is going to be about. When we are out in the world, we notice things around us that makes us wonder about how the world works. For example, while I'm working in the garden one day, I noticed that a plant standing in the sun is growing much faster than the plant next to it, which is in the shade. This makes me wonder if sunlight has an effect on plant growth. Step 2 was questioning. I have to now put my observation into a question. The question asks what I want to find out in the end. For example, does the sunlight affect plant growth? Do suns grow better or faster in the presence of sunlight? Or do plants need enough sunlight in order to grow? Step 3, hypothesize. This is where I predict the outcome of my test, and it doesn't necessarily have to be correct. Your hypothesis is a statement that predicts the end results of your investigation. For example, if we go back to our plant, we can ask, or we can state, plants do need enough sunlight to grow, or plants require sunlight for growth. This is a statement about what I think the investigation will tell me in the end. Step 4 is planning the investigation. I have to make a list of all the equipment that I'll need in order to conduct the investigation. I'm also going to write down a step-by-step method for the investigation and make sure my test is fair. Again, we are going to look at how to make sure your test is fair at the end of this presentation. For example, what I will need, I'll need 2 plants. I will need water to water the plants. I will need 1 spot in the sun where I'll put one of the plants and 1 spot in the shade where I'll put the other plant. I'm going to need a ruler to measure the plant's growth, and I'm going to use a notebook to record the growth of the plants. My method, so how am I going to conduct this investigation? I'm going to put 1 plant in the shade and 1 plant in the sun. Then I'm going to water each plant daily. I'm going to use my ruler to measure the growth of both plants. Step 5. Recording data. The findings of the investigation have to be recorded. In this specific investigation, I'm going to write down the measurements of both plants daily. So every day I'm going to go and I'm going to measure the plants and see how much they've grown, and I'm going to write it down. I can present the findings in a graph or a chart. If we look at this example, it tells us that this graph will show us the growth of plants in the presence and the absence of sunlight. Here on my axis I have day 1, day 3, day 5, day 7, day 9 and day 11. So I'm leaving out one day every time where I'm not going to measure. Here on the side I have the length in millimeters. So how long is my plant in millimeters? Then the gray line shows you the plant that was in the sun, and the yellow-orange line will show you the plant that was in the shade. When I look at the graph, I can see, for example, that the plant in the sun was growing much faster than the one in the shade. Step 6. Conclusion. I now have to put my findings into a statement, and I'm describing the data that I collected. The conclusion will also tell me if my initial prediction or hypothesis was correct or not. For example, I can now state as my conclusion that plants do require sunlight for growth, or plants need sunlight in order to grow. I can also say plants grow faster in the presence of sunlight. Step 7. Evaluate and communicate. I now have to state how I can improve the investigation. Is there anything that I would do differently if I had to do this investigation again? And then afterwards, I'm going to communicate my findings. For example, if I'm worried that my findings are purely coincidental, then next time I will use more plants in the test. I can put 3 plants in the sun and 3 plants in the shade to see if I'll still get the same results. We've now looked at all the steps that we need to go through in order to conduct a scientific investigation. The question remains, how can we make sure our investigation is fair? First, we have to identify all the factors that can possibly affect the test results. We have to keep the factors that could affect the test results the same. All the factors but one should be the same. We can change this one factor to see if this one factor has an effect on the end result. Let's go back to our plant example for a moment. When we are investigating whether or not plants need sunlight to grow, we will have 2 plants in our investigation. One plant will not be exposed to sunlight, and the other plant will be exposed to sunlight. To make sure that our test is fair, all other factors that can possibly influence the growth of plants has to be kept exactly the same for both of the plants. Both plants should receive enough water, because we know that water is another factor that can influence the growth of plants. Both plants should have access to carbon dioxide, and both plants should be planted in enough soil to grow in. If we keep all of these factors exactly the same and only change one factor, then we know we are testing for only one factor, and that's how we make sure that our test is fair.